Excellent. Here we go. Well, hello everyone. It's a pleasure to be here today. My name is Inty Gronnenberg. I'm the CEO and founder of a company called Ichthion, a company that we started in 2017 in London, the United Kingdom, at Imperial College London. And what we do is we develop technology to tackle the problem of plastic pollution in water streams, especially in rivers. We have pre-development so far, 3 different types of technologies. One system that is called Azure, that is the one that we are going to check today because it's the one that we are progressing the most in terms of technology readiness level. And we have other 2 systems called Cobalt and Ultramarine that they are still in earlier stages, in lab stage, that we are exploring still the principles of how these systems are going to work. But today I'm going to focus on the Azure system that is already in commercial scale. We have, just as a bit of background, we have spent around 3 years on the development of this technology. We got some grant from Innovate UK for the earlier stages, also some funding from the European Union, from Climate Kick. And then we reached a point that we were able to install the first full-scale system here in Ecuador in the Puerto Viejo River. We opened our offices here in Ecuador 2 years ago. And the goal of us as a company is to install 13 systems in Ecuador to stop the flow of plastic that is going towards Galapagos and helping to reduce the amount of plastic that is getting into rivers based on evidence. So today I'm gonna give you a bit of background of some progress that we have made with the technology and share a bit of experiences of how we are doing this process. Just a bit of background about, especially about what is happening here and how we decided to work and operate in rivers, based on some research that was done, especially given to us by the Grantham Institute at Imperial. We realized as a company in very early stage that a huge amount of material is flowing from rivers towards the ocean. So that's why when we started, we explored this possibility of installing systems in rivers to stop the flow. And another thing that also came from research of other universities, that a huge amount of that material in the case of Ecuador, because of the ocean currents, is going towards Galapagos. So plastic from the continent, especially from Panama, Colombia, Ecuador, and Peru, because of the ocean currents, is flowing towards Galapagos. And in one of the estimations that has been made is that around 33% of this comes actually from Ecuador. So that as a bit of the background. So what we came out as a solution is a system that I was mentioning previously, one of the 3 systems that now is in a commercial scale. In terms of technology readiness level, we are now in technology readiness level 7. Is a system that is designed to extract floating waste, especially plastic from rivers. The part that you are seeing, the mechanism that you are seeing on the screen right now is the mechanical part of the system. That is the one that is extracting the material, and the characteristic that it has comparing with other type of technologies is land-based. So because it's land-based, it has the opportunity of extract. We don't have restrictions in terms of volume of the material that we extract. So the whole extraction depends on the speed of the conveyor to be able to extract. So we have the highest capability of extraction at the moment in the market. Speaking about the market of this type of technologies, we have now around 20 companies worldwide. 3 years ago, there were only 3 companies. So it's a market that is growing in different regions. Another interesting fact about this technology is that it's mobile. So we can operate with the same mechanical system of extraction in more than one location in rivers. So the other part of the system that you are going to see, that is the floating barriers, they can be placed, let's say, for certain periods of time, and the mechanical system can be mobile and can operate in more than one barrier system. So these are a bit of some images of the project here in Ecuador, in Puerto Viejo. Is the first system of extraction in South America. We started the first phase this year in between January and June. The first part that we did is the floating barrier that was installed in a particular area in the Puerto Viejo that is called Pico Asa. Is a rural area, and people from lower income are living in this area. Is an area of a population estimated in 60,000 people that they live nearby the river. So the first part of our project that we have implemented here in Puerto Viejo were these floating barriers. They were manufactured in the United Kingdom, and the purpose of these floating barriers is to direct the material towards one side of the river. To make this possible and to analyze the designs, we have a testing rig that we use to simulate conditions of the river, and we test different configurations of the barrier depending how it looks, the shape of the river in the place that we aim to deploy. And sometimes if we have, for example, navigation, or we have other features like rocks or things like that, we can have other configurations of the system, like a cascade system, for example, that if you see my hands, instead of having one system that is directing from one side to the other, we can open the between barriers and then create a bit of, let's say, intersection between two, and then the material goes from one to the other, and we allow the gap for ships to pass. So this gap can be, amplified, and it depends a lot on how direct is the flow in the river. We try to avoid turbulence in rivers, basically, because that can create problems in this type of systems. But at the moment in the Puerto Viejo is a river that it doesn't have navigation, so we are able to put the whole system across. So once the material, or what we did between January to June, we operated only with the barrier, and we started doing sampling. So we were doing sampling, we were analyzing one part of the system that is really important, that is the mechanisms that, let's say, kind of the anchor system of the floating barriers, that they need to be capable to withstand the change of the depth of the river depending rainy season. So in the Puerto Viejo River, for example, in April, we had an increment of the depth of the river by 5 times. So it was really big, the amount of water that we received at one point, and we were testing how the anchoring system from both sides is going to react based on that differences, and it was working properly. We had to do some adaptations, but in the reality, at the end, is working without any problem. And then between July and September, the system also manufactured in the United Kingdom arrives here to Ecuador, the mechanical part of the system that was located in this ramp. And since then, we were doing testing, analysis, speed analysis, angle analysis, because also we have some capability of move the system in different angles to understand which one is the best. So the material that gets directed goes towards the mechanical part, and it can be extracted. And now at the moment is in full capacity. So we are now, the system is 100% operational. What we manually, for example, to give you an idea, before we were, it was taking 2 operators to extract manually from the barrier in one day. Now with the mechanical system, we do in 1 hour. So it's the capability of extraction raised significantly now with the mechanical part. And finally, in this area, we have installed a camera that is facing the conveyor, the blue part of the conveyor. And we are capturing images of what we are extracting. And based on visual AI, we are training an algorithm to be able to recognize the material that is extracted, because we try to obtain real-time data of the material, because what we have learned now is that it's very variable. So it depends on different conditions, sudden rain, the amount of rain, for example, because it's cleaning, let's say, places nearby rivers from the material that is deposited there, and then we have an sudden increment of material. Sometimes you have occasions that people can dump a significant amount. So we are trying to also analyze not only the content, but also the fluctuations of what we are extracting, to understand in a better way the problem in this particular river, and also trying to use this in other deployments that we are going to do. what we have been able to achieve so far, the capability of extraction at the moment is is more than 85%. So from the material that is getting to the point of extraction, at the moment we are able to extract around 85% of that material. And we are working on increasing that capability. So we want to reach at least 95%. And this is what the work that we are doing now. Training the visual AI to be able to recognize the material that we extract. Analysis of the environmental impact that we are doing also. For example, one of the changes that we did is that to put the conveyor perpendicular to the current of the river instead of parallel. So we minimize let's say the connection between the mechanical part of the system and the river, and also deciding the floating barriers and the depth. That is really important. And in terms of, let's say, competition, the system is the most cost efficient at the moment in the market, which is really good also for us and for our customers when we aim to deploy this in other areas. So these are some images of how the videos, I'm sorry, so of how the material is extracted. We have a mix of, you can see nappies there, for example. We have a lot of organic material, the water hyacinth, that we are doing analysis of what can be done with this material, and also with the residue that we extract from the river. This is a bit of background of amount, quantities, the variability that I was mentioning, what can be recycled, what cannot be recycled. The idea is that we are trying to work in projects to understand how to increase the recyclability of the material that we extract. This is a bit of an idea of the type of material that we are extracting, and this is so important to let's say assess and evaluate. One thing that we were not expecting actually, for example, is to get a lot of single-use plastic bottles. Why? Because in Ecuador we have a law that is create the whole let's say work of waste pickers, and it's a law that is companies here, they are able to receive back the money that they spend producing the bottles based on a scheme made by the Ecuadorian government in 2016. So one of the ideas that we have here in Ecuador is that actually the recycling capabilities of PET, the material for single-use plastic bottles, was quite high. But in the reality, what we are finding is that still there are a lot of spillovers of this material towards rivers and therefore the ocean. Something that we have as a hypothesis that perhaps this is happening, especially in rural areas. So with other deployments, we are going to be able to compare between rural and urban areas. And another one that is something that we were not expecting, and actually we are getting a lot, is plastic bags full of trash. So literally plastic bags full of trash that people, instead of, let's say, going towards the waste collection systems, are going directly to the river. So we did the analysis of what is the reason, and the reason is that in some rural areas nearby the Puerto Viejo River, they didn't have waste collection systems. So this also shows that the problem of plastic pollution with data and with these capabilities tells you and shows you that it's not only about replacement of materials, but also understanding the reality in different areas. So in this case, we were able to work with the municipality of Puerto Viejo to increase the collection route. So we expect that with this, we are going to see a reduction of the plastic bags full of trash that, of course, when they get into the ocean and the plastic bag gets degraded by the sea salt and the sand, then we see the spread. But actually, you know, what in rivers is the plastic bag full of trash. That is one of the main sources, and the reason is not only about the plastic material, also lack of waste collection systems. And this is let's say the power of the data when you see it, that you can take decisions based on evidence. A bit more about how it looks. The material is highly degraded. We were doing analysis of recyclability of this material. Because of the other chemical components that you can find in the river, most of the plastic in especially PET that we thought that could be recycled, quite high amount of this material cannot be recycled. So we are looking more towards the second loop in circular economy, that is reusability. So we are analyzing what to do with this material, and especially for materials for construction. And it's important to say that also we don't sell the material, because the company is doing a service of extraction, and with the material that we extract, we are trying to do projects with the community, so they understand about the problem in a better way. So this is perhaps for us the most important part, the work with the local communities. We work with the schools in part of the work that we do. We have also an NGO that is called Fundación Circular. The Fundación is working, especially working with the communities nearby the river, especially working with the schools. They did a really beautiful project that it came from their idea, close to the place that we are doing the deployment of the technology. They did a competition of, let's say, they created some charts made with recycled material, encouraging their parents of not throwing more plastic to the river. Very beautiful project, more than 20 charts made by them. That also is really nice how to see that the community also is getting involved in what we do. We do also some analysis on areas nearby, close to the shore, to contrast what we get in the river and what we find in places nearby the sea, especially in beaches close to this area. And what we can find is that it's different, the material that is flowing from the river, or comparing with the material that is being washed out towards the coastal areas. So especially because geometries of the material, not only the type of material, but also how it's designed, the material makes some material being able to travel higher distances and not also getting stuck in the shores, but going directly towards the open sea. This is also an additional part of the work that we do with the communities. In some areas that we saw that they were throwing material, because you can see in that areas in hills, for example, close to the river, you can see let's say the debris of the material where people got used to throwing the plastic bags, for example, towards the river. So we are building this sort of let's say viewpoints, if I can say that in English. So some viewpoints that the community is working. We give them materials and we work with them. In the future, we are planning to do this with plastic wood. So to be able to, because at the moment they are not seen towards the river. It's more like, the river is the dump place for communities, and they try to avoid to see it. So societies here, especially in Ecuador, are growing, basically looking not towards the river, towards the other side. So this idea is to work with them to make them see again the river, how beautiful is the river if we keep it clean. And it's creating a really nice impact, because they work with us in these constructions. We also, because in the evidence that we found in the Puerto Viejo, because of they were not having a waste collection system, so we are also creating a trash point, so they can now put the material there, and the waste collection system is picking up. So the idea in this 3-year project that is going to last 1.5 years more is doing a lot of activities with the community, building more of these bridges, more work with the schools. So we are hopefully decreasing the material that is ending in the river. So that's a bit about us.